Okay. Um, we finished with the Python solution for the assignment on Tuesday. So we are going to learn how to make a code for the relevant problems on machine learning. So in this case, I would like to explain about regression. And we are going to use the linear regression. As you may know that the regression or the linear regression, we have some data and the target is numerical data. So if the target is numerical data, then we need to apply regression techniques, or we need to apply the regression approach. So in this example, I would like to give you three different algorithms: linear regression, ridge regression, and lasso regression. And we are going to use one data set, which is housing data set. Okay, what is housing data set? Let's see this housing. In this data set, you can see several columns. So we can see the column price. So it means this is the house price. And then we can see lot size. Lot size means the size of the house. Maybe if it is an apartment, then this is the size of the apartment. And how many bedrooms? How many bedrooms? And also we have other columns like stories. Stories means how many levels of the room, and driveway, whether the house is in the driveway or not. So if it is yes, then it is in the driveway. If it is not, then it's no. Whether it is a recommended room or not. So if you go to the online, then maybe people would like to give a recommendation. So this room, the room number one, it can be the room is not recommended. This one, the room is recommended, and so on. Full base. So full base, usually I think in Korea you have like full option. So you can have options. So this also have some kind of that one. And whether the house provide the gas for the hot water, whether they have yes or no, and whether they have the air conditioner, no or yes. And then they also have the information about garage, whether they have the place for parking car, parking lot or not, and whether it is a preference area or not. Preference area usually maybe it is in the good place for foods or good place for mart. Is it near market and etc. So you can see the data is about yes and no. So using this data, if I know the other components, if I know the other data, or if I know the other attributes, can I predict the price? So the housing price usually it depends on the maybe the room size, how many bedrooms and how many stories and etc. So I would like to predict the price. If I know some data, what is the relevant price? So we can make a model with this data. With the code in Python, first I would like to call the relevant libraries. So in this case, I'm going to use matplotlib. It is for the visualization. Okay. NumPy, I think last time we already know, this is for the visualization. NumPy, it is for the numerical data processing. And then sklearn, we usually use this for the modeling. Okay. And pandas, last time I mentioned to you, it is the Python for the data analysis. So first we would like to load the data. The data that I give to you is housing. I use the folder data, but here the housing is not in the folder, so you can just delete this. And then I would like to separate the Y and X. So Y is the target. I would like to know what is the target, and X is the explanatory variable. It can be one or it can be more than one. So now I'm just choosing one. So the target is Y, and then the X, it can be one or more than one. So the target is price, and I would like to know based on the lot size. So if I know the size of the room, can I predict the price? So this is the problem statement. So this also the same with your team project. In your team project, you need to define what is your problem definition. If you can make it clear, your problem definition, then you can specify what is the X and what is the Y. So in this case, I would like to predict the price, and the column is price. And I want to predict the price based on the size, then the X is the size. So when you do the team project, make sure that you know the problem definition clearly. And after that, here, I just want to change the shape. So in this case, the data is in the format of data frame. In order to make into the machine learning, we need to change the shape into a series or into an array. So we change the shape, this one. And after we have the new X and we have the new Y, after just reshaping it, now we are splitting the data into training and the testing. So the training and the testing here, we have X, and then we have colon and minus 250. So the data is about, the data is 545. And among those data, I would like to take 250 as the training. I would like to take the last 250. So this one is minus 250. It means the last 250. Okay. The last 250 data, it will be taken as the testing data, the test set. So the beginning 0 until the beginning of the data until the last 250, it will be the training set. So let's say if I have 10 data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I say that this one is until minus 3, then it will be 1, 2, 3. So the third last data. It means all the data until the third class of the data, it will be for the training. And then this tree, it will be for the testing. Okay. So that's the meaning by this one. So this is manual split. We have the X for the training and we have the X for the testing. And then I need also to do the same for the Y. I have Y training and I have Y testing. And the splitting is the same with 250. After you have the X train and X test, now I would like to make a plot. What I'm going to plot is the X testing and then the Y testing. And what I'm going to do now is, in this PLT means the plot. So I'm going to plot the scatter plot. Scatter plot means, I just want to put the data in the X test. And I also want to put the data on the Y test. So this is the X test and this is the Y test. And then the title will be the test data. And then the X label will be size and the Y label will be price. So I'm going to use ticks for the X and I'm going to use ticks for the Y. And let's create the linear regression. So I'm using the linear model. This linear model is from this sklearn. We have the data set and then we have the linear model. So I'm using the linear model and in this case I'm calling one algorithm. It is linear regression. So I'm making a new variable track with referred to regression and I'm going to fit. So if you still remember, we learned that it is model creation. The model creation means I want to create the model based on the X and Y. So this is the X training and this is the Y training. After I make the model, so I need to model evaluation. I need to evaluate the model. So we learned also already about these things. In this case, I'm just plotting. So I'm going to plot the X test and then I'm going to plot the regression result after we do the prediction. Or this is the model. And the model will be in the red color. So you can see that this is in the red color. So this is the model that we created using the linear regression. So I can run this. Okay, the result is one. We have the X is size and the price is Y. Now I can check the other kind of algorithm. So I would like to see if I use RITS. This is another regression algorithm. So if you use Python for your team project, then you can make sure what kind of other algorithms that is suitable for comparison. So I'm going to use RITS. It is another linear model. And I'm going to fit it. Okay. So again, it is model creation. After I create the model, again, I need to model evaluation. So if I have the model, then I would like to check the score, which is the score from the X train and the Y train. And I'm going to check also the score from the X test and the Y test. So the result is this one, and this is the result of the R square. Maybe if you learn the statistics, you know this is the R cubic. This is one of the performance measure for regression. If you still remember, when we learn about the prediction, if the class is numerical data, then the measures we can use RMSE, which is root mean square error. We can use MSE, which is mean square error. We can use MAE, which is mean absolute error. Okay, and yeah, we can use the R square. If we use the RMSE, if you use RMSE, closer to 0 is the best. For the MSE, it is also same. Closer to 0 is the best. For the MAE, it's also the same. Closer to 0, it is the best. For the R square, what about the R square? Closer to 1 is the best. Okay. For the RMSE, MSE, and MAE, it is based on the error. So the error rate should be low. If we use the R square, then it should be high. Based on this result, the R square for RICS is 0.16. Is it high or low? Yeah, it's not that high. Usually we can say high if the R square is around 0.7 something. But this is very low. That's why you can see also with the linear regression. Yeah, the line is here, but the data is here. So it's very, there's a big gap between data and the model. Now let's see if I use another algorithm, which is Lasso. So you can check on the dictionary about the linear model. Now I'm using just the Lasso CB. It is another algorithm for the regression. And again, I created the variable model Lasso, and I do the model creation. And after I do the model creation, I need to model evaluation. And with the same way, we can get the R square for the training set is 0.16, and then we have the R square for the testing is minus 0.07. So it's very low. Then in this case, you need to find another algorithm which is the best for this result. Okay. So I'm not sure whether you are going to use Python or ORI, but let me just give you a guideline if you want to use Python. So the basic classification, we know that the regression is having the target as numerical data. But if it is classification, the target is categorical data. And there are three algorithms: random forest algorithm, decision tree, and K and classifier. Okay, let me show you one by one. In this case, we are going to use the iris dataset. Do you still remember iris dataset? So the iris dataset is the flower data. Okay, so we have the three flowers: Iris setosa, Iris versicolor, and Iris virginica. And the data is something like this one. We know the sepal length, we know the sepal width, we know the petal length, and we know the petal width. And we know what is the species name, what is the flower name, whether it is Iris setosa or Iris virginica or Iris versicolor. So I'm going to just import the relevant libraries. Like for this one, I'm using the model selection. So this will be used for splitting the testing and the training. And here is the ensemble. Okay. We will use one algorithm, which is random forest classifier. And I have the label encoder. And I will like to show you the confusion matrix, the accuracy score, and the classification loop. The first is to import the dataset. So I'm using a web link here. So if you want to see, you can go to this link. Okay, so it will be downloaded. So you can see the data is now downloaded. Oh, okay, I already downloaded before. And if you want to look at the data, you can open, let's say I'm having a notepad. Okay, if you have the notepad in your computer, you can also open the data. Okay, let me just open the new one, that I just downloaded. So the data will be something like this one. 5,1, it is the sepal length. 3,5, this is the sepal width. 1,4 is the petal length, this is the petal width. And this is the flower name. Okay. So I'm going to read this file, and then the separator is comma. What does it mean by this? The separator here is comma. Comma. Then every comma, it means it is different data. And then header equals to null. So in this data, I have no header. So the data has been started in the row number 1. It means there will be no header. I'm going to use all the data. So ilog means I'm going to check. This is all the rows and this is all the columns. So all the rows and all the columns will be set into the variable data. As you might know, when we do the data preprocessing, we need to check the null values, okay? Check the missing values, whether there are some missing values or not. The missing values will create your results. So I would like to check what is the null values. Is there any null? This is the command data is null dot sum. So we will check the result later. And I'm going to make the x and y. So we have x, we have y. Y is the target. In this case, the target is the flower name. So the flower name, if you learn Python, you will know that this is the column number 1, column number 2, column number 3, column number 4, and column number 5. But Python always start from 0. So this is the index column 0. This is the index column 1. This is the index column 2. This is the index column 3. And then this is the index column 4. Okay. If we are reverse, or if we start from the back, we call this is the column -1. This is the column -2. This is the column -3. This is the column -4. And this is the column -1. So if we reverse from the last column. So if you look at the code, you will see that the X will be, this means we will use all the rows. And for column, we are going to use the all columns until -1. What is -1? We have 0, 1, 2, 3, 4. And we can say this is -1, -2, -3, -4, and -5. So we are going to use all the columns until -1. And for the Y, I would like to use all the data, and I'm going to use only the column number 4. Okay, so that's the way to read this code. The values means, yeah, I just want to get the values and make it into the variable X and Y. The next is label encoder. The label encoder means I want to encode the labels because now the label is categorical data, iris setosa. And the computer cannot read this categorical data. They cannot understand. In order to make it understand, then this iris setosa should be changed into numeric. So by using the label encoder, it can be changed to 1. And then if you have iris versicolor, then it will be changed into 2. And if you have another flower, which is Iris virginica, it will be changed into 3. So that's the meaning by the label encoder. So I'm going to change the Y with the label encoder and make it into the new Y. I'm going to split the data. So we have X train, X test, Y train, and Y test. And in this case, I'm going to use the train test split, and the test size is 0.3. What does it mean? Model data, we have 100%. 0.3 will be the test size. So 30% will be the test. So the remaining, which is 70%, it will be the train. Okay. So you can change actually. Let's say I do not want to make it 0.3. I want to make it 0.2. Yeah, it is fine. So it is up to you how you want to define the testing and the training. The random state means the state that you start the random numbers. So if we set 0, then my random numbers will be the same as your computer. Because whenever we run random, so the computer is really random. We do not know what is the result. My result will be different with your result. So in order to make it the same result, yeah, we can set the random state equal to 0. Now I'm going to use one classifier. We call it the random forest classifier. So this way is the variable from the random forest classifier, and I'm going to fit. Okay. So fitting means I'm going to make a model, or it is the model creation. So I'm going to do the prediction. Okay. After I do the prediction, then I can do the model evaluation. So this tool is always be in the classification. The first is the model creation. After we create the model, here we want to predict based on the X test, and the result it will be in the predicted variable. In the model evaluation, I think you still remember confusion matrix. So I want to know what is the actual and what is the predicted. So I'm going to use the confusion matrix to check the Y test and the predicted. And I'm going to check the accuracy between the Y test and the predicted. And I can make the report based on the Y test and the predicted. So if you run this, then you can see, okay, sum of null values in this column. Okay, the column 0 has 0 null values. The column 1 has 0 null values. The column 2 has 0. The column 3 has 0. And the column 4 has 0. And the confusion matrix is like this one. It means this is the actual and the column is the predicted. This is 1, this is 2, and this is 3. This is 1, this is 2, and this is 3. So 16. What does it mean by 16? There are 16 objects which the actual and the predicted result are the same. Okay. So there are 16 objects. The actual and predicted result are the same. 17. 17 means there are 16 objects which the actual and the predicted result are the same if it is in the second object. The second object means if you look at the data, the first is Setosa. Number 2 is versicolor, and the number 3 is Virginia. So the total accuracy is 0.97. And you can look at the precision and recall for every class. This is the class 0, this is class 1, this is class 2. And the total accuracy is 0.98. So it is the round up values. Okay. We can use another classifier, which is decision tree classifier. In this case, I'm going to use again fit. Fit is the model creation. Okay, and then I'm going to predict it. After I predict, then I will do the model evaluation. Okay, the result is the same with the random forest. And this is the precision, recall, and the accuracy. And the last, I would like to use the KNN neighbors. KN neighbors. So it means the K nearest neighbor. Using the K nearest neighbor, again, I would like to make the model. And again, I would like to do the model evaluation. Okay. So if you use Python, yeah, I give you some guideline. This is the very basic guideline. You can use it for your team project. Or if you want to use Orange, yeah, that's also fine. As long as you can do a very good explanation, and also you can make the flow from the beginning until showing the performance measures of the classification or the regression. Okay. Any questions? Okay, feel free to use any of the tool. So in this chapter, I'm going to explain about the basic concept of cluster analysis, and we are going to learn the partitioning methods and the hierarchical methods. So what is cluster analysis? We call cluster is a collection of data objects. A collection of data objects. We can have two different perspectives, similar and dissimilar. Do you still remember? We have the similarity, okay, and we have the dissimilarity. So if you go back to the previous chapter before the mid exam, we learned about those two. Similarity means I want to check the similarity between one object and other group within the same group. So if I look at this data, yeah, the red color, they are similar. That's why they put it into the same group. But the blue color, yeah, it somehow is very far from here. So it creates a different group. And also the green color. The green color and the red color is very far. So that's why it creates that one group. So the similar objects are in the same group, but the dissimilar or unrelated objects, it will be in other groups. So the cluster analysis, it means we can use clustering or we can use data segmentation. We want to find similarities between data according to the characteristics found in the data and grouping similar data objects into clusters. So this is the definition of the cluster analysis. So we learned already about the unsupervised learning. Unsupervised learning means there will be no predefined classes. If we have this figure, we have this figure, we have this figure, I have no label. There is no information. What is this image? So I'm just using the clustering to check whether they are in the same group or not. Because this is learning by observations. And if you are doing with the supervised, yeah, we call this is learning by examples. So the typical application is it is as a standalone tool to get insight into data distribution. So if you use the orange, yeah, you can apply the data distribution like using binning. With binning, you can split the numerical data. Or you can use the clustering as a pre-processing step. If you still remember the self-supervised learning. The self-supervised, you need to apply clustering first, After you got the result from clustering, you can do the classification. Okay. Now let's see. Let's suppose I have this kind of data. Okay. Commonly, clustering could solve a problem as unsupervised learning. We can store features in the database without any links. For example, I have phone ID. So this is phone ID 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 data. Maybe this is like Tunggupun. Tunggupun dari the second handphone. Okay. So I would like to know, based on this data, can I make some characteristics? Let's say the battery means how long the battery can last. It will be in hours. So the phone number 1, the battery will last for 12 hours. And the camera means the camera pixels. So maybe this is 8 megapixels. So this phone number 2, we have battery 26 hours and the camera is 16 megapixels and so on. If we have this data, how can we analyze the smartphone that we have? So I can use the distance measures. With the distance measure, or maybe I can plot like this. So after I plot this, then okay, maybe I can separate like this one. So this is the data number 1, the data number 3, 4, 6, and 8. It is below at some point. But if the data is 2, 9, 7, 10, and 5, after I plot, it is in the upper side. Then I can say that the data that is here, it is belong to cluster 1, and data here, it belongs to cluster 2. Then I can express my data using the stored features in the database. We can measure the distance and create clusters. So the clustering problem can now be expressed as like this one. We have the database, my collection. We have the database, my collection. We want to create the possible class labels according to the similarity or the distance of features. Because I know the distance of the features, then I create this one as cluster 1, I create this one as cluster 2, cluster 1, cluster 1, cluster 2, cluster 1, and so on. This is based on the distance measure that we have before. Okay, let me stop here. Let's have a break. I will continue after the break.